Hello, I'm Richard Haig. I'm Director of Technology for Just Eat, and I specialise in reliability engineering. And this is...
So I'm Benny Johnson. I'm the Head of Site Reliability Engineering. I've been at Just Eat over 5 years now, and came from development into the product delivery side, but now working on the operations side for site reliability.
And we're going to spend about the next half an hour talking to you about how we do DevOps at scale at Just Eat and our site reliability engineering efforts. But before we begin, I'm going to tell you a little bit about Just Eat. Quick show of hands, who here has used the app? Benny, hopefully? There we go, good. Okay, so those of you who have will know that the app is basically a marketplace. And what we do is we link tens of millions of customers around the world in about 13 countries to tens and thousands of local restaurant partners. And we link up people who want to enjoy great food with those that are able to make it and deliver it. And our mission, our vision is creating the world's greatest food community with that marketplace at the heart of it. And of course, at the heart of that marketplace is technology. Now, because you're a tech crowd, I wanted to put that into context. And this is a slide that myself and all of the guys will show in front of every talk we're doing. And it's really to put the technology that's at the heart of Just Eat into context. So we have around 500 people in tech across 5 or so different sites, around about 23 million active customers on the platforms at the moment. But on the software engineering side, we're more than 35 software development teams with around about 450 different microservices all working together to provide those platforms. At peak, we're putting out around about 2,700 orders per minute. That's usually on a Saturday evening, no surprise. And in order to provide that, we spin up in excess of 1,500 instances in AWS to provide that infrastructure for us. We ship metrics by the metric ton, pun intended. We ship logs by the terabyte. And the pace of change is relentless. We can get up to in excess of 500 software changes, releases going out per week at times. So the whole DevOps, the whole SRE thing is quite important to us. Financially, commercially, we're growing around about 40–45% per year, which gives its own challenges when you're trying to provide technology to support that. But as a result, we're a FTSE 100 company with upwards of about $5.5 billion in market cap. And we do some cool things well. So amongst other things like Alexa, Xbox, etc., we've also played around with using robots to help deliver our food, which if you've lived in Greenwich or somewhere near over the last year, you might have seen them trundling around. But now you understand a bit about Just Eat, let's talk a little bit about what is site reliability engineering at Just Eat. And it all starts with this first premise, and that is that we believe truly that dev teams own their product, full stop. So the devs create the code, they produce it, they ship it, they look after it in the evenings, they take the pages home, we call them at 3 in the morning if their code fails and they help fix it. They own that product, full stop, cradle to grave. But they don't do it on their own. We have a whole group of people that help them do that, and that is our SRE teams. And we run those teams off 5 main pillars. The first one is no surprise, we relentlessly protect site availability. We go for 3 nines 5, and we hold ourselves accountable to that every single month. We strive to better that target. We also try to enable change to be delivered fast, but baking quality in. And that's all about automation, those delivery pipelines. And we work especially hard to reduce the time that it takes from when a developer checks in code to that code serving production traffic. And we want to make that time as short as possible to avoid the development team's context switching, getting distracted, going on to other work. We also have a pillar that looks at optimizing the use of our infrastructure and our resources. So we use scalable cloud solutions to underpin all of our work, but with that comes a credit card somewhere. So we have to make sure that we spend the right amount of money producing that and being as efficient where we can. And the last 2 are a little softer, but I think just as important. So we try to innovate to stay ahead, specifically in the world of tooling. If you just look at AppD's announcements this morning, tools change so fast and so frequently that we have a job to always be looking out at what's available, be it commercial, be it open source, or be it something that we need to build ourselves to make sure that we're consistently providing the best tooling for the job to our teams to meet those former 3 pillars. And then lastly, a very important thing at Just Eat, it's up to us to help foster and keep that culture right. We want teams to be as autonomous as they can. We want people to be able to fail fast. And to do that, we have to support a really good, blameless culture, a culture that fosters that engineering and that intelligence. So here's how we structure site reliability engineering at Just Eat. We've got a large customer base, that kind of 30+ development teams, and that can sometimes change. We'll bring on teams for other projects. So we need to be able to scale and move around with that. And to do this, we have a central reliability engineering department. There are about 50, 60 heads, and they cover the following things. So we have a 24/7 service operations team, a couple of guys in the audience today. Hi, guys. Their job is to boss the first 10 minutes of any problem we've got and make sure that we do the best we can for those first 10 minutes. And why 10 minutes? Well, that's about how long it takes to get our development teams out of bed, onto their laptops, and bring the experts on site to really understand what's going on. So these guys are critical at keeping that time to resolve in the shortest time possible. We have a development team, and they not only look after things like some of our load testing strategy, where we've had to build some of the connections in with our systems, but they also support that service operations team, building the things that they need to operate the platform in an automated fashion, to avoid us having to think at 2 in the morning, hang on, which order do I do this in, which lever do I pull first? We've got a team that looks after the hosting and the platform, so I talked about AWS, but we also have workloads in Azure and also in Google Cloud Compute. So we need to have teams that understand how best to use that, how to surface those infrastructure capabilities to the development teams in an easy-to-use way. Delivery automation, that's CI, that's CD, so those pipelines, creating the best-in-breed way to get code down those pipelines quickly, make sure it's tested, make sure it's secure, make sure we understand the risk, and then to turn the frequency of that up into the tens to hundreds of releases per day. We have the trendy term observability. For those that don't know it, that's your monitoring, logging, alerting. So we've got teams that look after and maintain some fairly large tooling around our time series and our event-driven monitoring, alerting, and logging, and making sure that that's in a fit state so that we get the right alerts at the right time, no false positives. We're waking people up for the right reason. And then we wrap this all with some service management. So our 13 different jurisdictions have country managers. All of those are a commercial part of the business, and they need to understand the impact of an issue or an incident or a risk that we're carrying. So we have a small team that makes sure that that message is carried across and goes out to the business in the same way. And in order to embed this reliability engineering department into the rest of technology, we have a cadence of several ceremonies that we run. So we run a daily production stand-up. First thing in the morning, we get together for half an hour and review everything that's gone wrong in the previous 24 hours. And we use that in order to help the teams prioritize what to fix next, or if we can help centrally, what we can do next to try and push that ticket further towards the solution. We run a weekly risk meeting. So before we go into our busy weekends, and it is the weekends that's busy for us, we make sure we understand exactly the risks that we're carrying. And we make sure that engineering is in the room talking about their understanding of what's currently at risk, what the mitigants are, what we will do if we see it manifest, etc. And then once a month, we get all of technology together and we run an operational all hands where we talk back about the problems we've had, the lessons we've learned, and the new exciting tooling or the features that we're bringing over the coming weeks. But most importantly, and this goes back to the devs owning everything, the site reliability engineering team gets embedded within technology, and we're a first-class citizen. So whether we're talking architecture or we're talking a way that we're going to launch a new product, we're in there with the developers, part of that conversation right from the start. So let's talk a bit about the tools and the processes we own. Now, this can go one of two ways, and I've seen in both extremes. So in one extreme, my team, we own all the tools. And that's great, because it gives me economy of scale, and it gives me a way to make faster decisions. I own everything, so I can change everything very quickly. Brilliant, you have to take it. But it limits innovation. Everyone has to do it my way. And while I think I'm okay, I might not be the cleverest guy in the room, so maybe there's other ways to doing it. And it slows down the development teams. They've always got to accept the stuff that we want them to have. They've always got to adopt the things that we need them to. And that can get in the way of their planning and the way that they're pushing products out. So maybe we go all the other way and we go to the other extreme and we just let the devs be completely autonomous. And each of those teams does exactly what they need. Well, that's great because it gives those teams maximum flexibility. They can react to anything they need to. They can take the latest, greatest, whatever they've heard down the pub, bring it in and start using it immediately. But we end up with massive tooling sprawl with maybe tens and tens of different things being used over and over again, reinventing that wheel. Testing is a great example. Lots of different tools out there to do it with. And it gives a support problem. A team comes, they bring in something, they embed it, that team disperses, goes somewhere else. Who supports that? Who takes that tool that no one else knows? So, of course, we've settled somewhere in the middle. We've tried to support that diversity, that decentralization, but at the same time try and hold on to and control some of the things that are larger in scale and more important to the business. So we have central support for a range of tooling, especially if they're big, like a monitoring stack. But we give the dev teams the ability to interact with that, very much in an open source way. So they can take a version of it, fork it, change it, manipulate it, make it work for them, and give it back to us, and we can look and say, yeah, that's great, others would like that. Let's incorporate that back into the code base and send it out to everyone. We give freedom for the teams to deviate. So having said we try and control some of it, if you run a dev team and you desperately want to use ToolX, we're not going to stop you. You go into that understanding the risks of taking that on your own, and we'll support where we can, but it's best endeavors at that point. But there's also survival of the fittest. If you've chosen that tool and it turns out to be absolutely awesome, I think I've seen this with something like Slack recently, the next team takes it, the next team takes it. Do you know what? It gets to the point where it really is the best in breed, then we'll look at taking that aboard and seeing if we can apply some of those economies of scales and some of that enterprise support to it as a central tool and help make it easier for others to adopt it. So that's how we've got to where we are now, Benny's going to talk to us a little bit about the history of how we got there.
Cool, cheers, Rich. So as an overview of where we are now, this is sort of how we got there. So if we look back, sort of 4 years, there wasn't, Just Eat was a small startup, well, a big startup really, but we had sort of about 10 delivery teams, and these are the DevOps teams. This isn't, we didn't have a DevOps team. We practiced the practice of DevOps. All these teams were responsible for their own code in production. All these teams were responsible for putting it in, supporting it, monitoring it, all that side of things. Obviously, we needed some kind of central support. So we had a platform as a service team. Now this wasn't central control. This wasn't your deployment team. They didn't look after deploys. You didn't have to run things by them. They were a platform as a service team. They provided the deployment tools, the monitoring tools that helped these DevOps teams really, get stuff into production. And as Rich said, it operated on a as a service model. If one of these teams was like, actually, your monitoring stack's no good for me, you don't have the resolution we need, I'm going to go build and host my own and run it, we'd have big questions about what on earth is on their priority backlog if they can spend that much time on monitoring. But, they were free to do these sort of things. And this worked, we were sort of doing, probably as a company, about 1 release a day at this stage. So with these development teams, you'd only need really about sort of 6 of these on-call engineers. Each team would have their own on-call rota, would be on-call for their own things. But between about 6 of them, they would have eyes that covered the whole platform. They would know everything that was going out because they were the ones that were building it, those were the ones that were deploying it. And with only about 1 release a day, a rota for a developer in one of these teams, they were on call probably about once a month. You had sort of pizza-sized teams. And so if you're on call 1 month and a month later you're on call again, there's only been about 20 releases into the platform. So it's quite easy for them to keep up to play with the state of the platform, how it was changing. When things went bang in the night, they could easily go, oh, well, remember those guys were changing that last week? Yeah, well, that's probably related. Let's go and sort it out. And this was great. We loved being agile and doing DevOps. But Just Eat was successful, so we scaled. And this started to bring in a lot of problems trying to scale DevOps at Just Eat. So this sort of time slice, our dev teams have doubled again. So you're looking at probably about 20 of these product delivery teams. But also, the health of these teams and the process of these teams, the code base they're working on has improved so much as well. We're fully in the cloud at this stage. We're doing 5 releases a day, across the company. So now, any one of these developers are now, instead of just 6 of these teams to be able to cover the whole platform, you're really looking at more like 16 to cover the whole platform. And with 5 releases a day, the next time one of these developers comes back on call, there's been about 100 changes to the platform since they come back on. It becomes very difficult for them to really understand what's changed in the platform. And they didn't feel the same level of ownership as they did when there was only, sort of 5 of them on call one night. They'd know everything that was going on. Now you've got 20 people on call. It became very much a game of, oh, my metrics look fine, my graph looks fine, must be someone else's problem. And we really struggled with that sort of accountability and ownership of the whole platform. So we brought in an operations team. And again, they weren't there to control what was going out into production. It was still a DevOps model. It was the development teams that owned their code in production. Our operations team were there to monitor what was going on and would love it if they would respond quicker than our developers could because they were sitting there 24/7 running their shifts. How do you make them aware of what's going on? Well, we look at what the big companies do. Okay, well, let's give them runbooks. Let's make every team produce files on every service that they own that says, this is my service, this is how you monitor it, this is how you deal with incidents, these are the 3 most recent incidents I've had, and here's some scripts you can run to take us back to a working state when you get problems. Which, sounds good, and if you've ever tried it, you'll realize it's terrible. You'd get a production incident on a Friday night, they'd open up their runbook, there's some scripts that assume some permissions for some login for a database that no longer exists. These things, don't stay up to date. They don't work. I think, probably the worst case is when you open up a runbook and find it's copy and pasted from a completely different service and they haven't even bothered updating the names. We've got a runbook. It's not actually for the service you thought it was. So, it was good having eyes on the platform. It was good having the holistic view. But really, runbooks weren't the way that we were going to scale DevOps. Of course, Just Eat kept being successful. We kept making more orders. We kept convincing the business that if we're making more orders, you need to hire more developers. So we got more and more dev teams. And this is sort of where we are today. So our platform as a service teams sort of needed scaling, and this is what Rich was talking about here with the deployment and the monitoring, and it's the best I could find for database and the icon set I was looking at. But you know, the biggest change came over on the operations side. So you know, runbooks weren't the way of doing this, and this is where Nick Walters, who was head of the operations team at the time and still is now, went out to market and looked, you know, what are the tools that can really help us with this? And this is where sort of, you know, AppD came in. This is where our internal SRE dev team started building tools, you know. Okay, it's interesting you have runbooks, but really, what are those big business transactions? What are the ones we really care about? And can we have buttons and levers for our operations team that allow them to affect the flow of traffic, that protect that core user experience? And that was, you know, it was also the megaphone. You know, their job wasn't so much, you know, they've got the buttons. If it's a known problem, they've got buttons to push. But their job is corralling this herd of developers and making sure the right people are online at the right times to solve their issues. Yeah, and at this stage, we're up to 500 releases a week. So, you know, without a central operations team with eyes over the platform, it would be impossible for us to have continued and scaled DevOps. But crucially, we've done it in a way that we're not taking ownership away from our developers. It's something that Just Eat's always been built on and hopefully will continue. That's sort of how we got to where we are as a company, as a team size. This is talking about some of those tools. So when you've got 40-odd product development teams that, you know, are accountable and independent and own what they produce, how do you control them? You know, we don't do the very centralized command and control, but we do know what good looks like, and we do know when someone isn't looking good. So we've built a tool called Scorecard, and this is our sort of reliability-based tooling that we use to help us understand how well teams are engineering, how well they're architecting, how reliable we believe they are. And so for a team like Global Device Platform, we can see that they've got an A rating, which is good. And for each of the services components they own, we can see the individual scores. You can drill into each one of these, and you can see, you know, there's a checklist of things that we run against, how you're set up, how you're architected, various different. Some of them are piecemeal projects that come in ad hoc. So you can see they've got a little ghost badge up the top there. I'm sure a lot of you remember Spectre Meltdown. You know, it was important for us that all of our servers across all of our estate were Spectre and Meltdown patched. I don't own those servers. Rich doesn't own those servers. 40 development teams own their own slice of all those servers. We, as our platform team, provide the services, provide the, okay, here's the latest AMIs, here's the VMs that you need to upgrade to. Our tooling provides the monitoring, and we just pass that back to their bosses on their side of the business. Well, here's your reports. Here's all the teams that have done it. Here's the ones that haven't. It's not up to us to enforce these things. It's up to us to report on these things and help them enforce it themselves. Another tool we use, AppDynamics, obviously. We wouldn't be here if we didn't. But as I said, you know, one of the problems we did face that AppDynamics really helped us with. So we had monitoring as a service from very early on. It was one of the things that allowed us to do DevOps. If you're operating something, you need to be able to see it. But because that was built out of the teams, that came from individual features, individual components, individual services, which is great. So, you know, for, I don't know, the order API, we have some great metrics. We can see how it's responding. We can see how its CPU looks, how its memory is looking. But from the operations point of view, we had very little visibility of what was actually going on in our platform. We didn't even really have a real-time order rate. You know, this was something that came out of our database from BI, you know, 3 days later. And whereas AppDynamics gave us the ability to look across all of our teams and across all of their services and correlate all the calls across. And from an operations side of point of view, as well as from an architectural point of view, it really gave us that visibility of what was going on in our systems. So that was the tools we were using. And then we still, you know, well, having an A rating for a team was good. You know, some teams are gamified, you know, they're developers. You give them an A or, you know, give them a C and they'll quickly make themselves an A, no matter what they've got on their backlog otherwise. But we needed a way to help sort of push change into these teams. We needed some way that we would drive the behaviors we wanted. This is our pseudocode because, you know, we're ex-developers. And this is what helps us drive the right behavior across the development team. So we have a reliability score, which we drive mainly from Scorecard, but there's also a few little spreadsheets of people that are tracking bits that we haven't quite codified yet. that'll give us our reliability score. And that's good, that's a score. You know, a component can be an A, a component can be a C. And that's, yeah, you'd think, is the A therefore better than the C? Well, it's more reliable. Does it have to be though? So there's a desired reliability built into every component as well. So obviously, you know, payments processing components, they need to be very reliable. You cannot stop taking payments. But, you know, the component that drives the little thumbs up and thumbs down icons on menu icons on an app, if that stops working, our customers still order food, our restaurants still earn money, our drivers are still able to deliver food. I mean, it's not something that needs to be as reliable. There's not that much desire, you know, do you really want to go and make sure that's an A, make sure that has, you know, 5 nines uptime? That's a waste of time. You know, it can go down for an hour. Sort of, you know, in theory it'll hurt conversion because, you know, we would be doing it for a reason. But, you know, it's not as important. So there is a desired reliability involved in all of our features. And then if you're not meeting that as a team, as a component owner, SRE's job is to help you with that. We're the ones that have eyes on the whole platform. We're the ones that look at individual teams and see the patterns. We see the problems other teams are facing. And we can therefore go out and second into teams and help them with certain problems, help get their reliability score up to where it should be. But then, you know, that's good. Help. If all you're offering is help, all the dev teams will always take all the help they can get. You know, every dev team just wants people to come and do their work for them. So you've got to have the flip side as well. Like, why would they want to get their reliability score up? And so that's our side of the statement. So we highlight them. We do a lot we do a sort of newsletter every month where we'll highlight sort of good behaviors we've seen in our all hands that Rich talked about. Again, we talk about, you know, the teams that are doing the right practices, the right patterns, but we also increase their freedom. And this can mean many things to many different teams, I'm sure, in different companies. Probably the key part of that for us around freedom is release windows. It's one of the bits of control we really do have. Obviously, you know, if you're releasing a feature that can take down ordering from consumers and your reliability score is hypothetically very bad, we don't want you doing this at 7 o'clock on a Friday night. So we have quite restrictive release windows for different sort of desired reliabilities. And if you're performing well, if you're the sort of team that is releasing small incremental change often, if you're betaing all your releases, if you're canarying, if you're doing A/B testing, you know, if everything's going smoothly and your uptime is always smooth, sure, you still can't release at peak, but you can release a lot closer to peak than a lot of the other teams. And it's just that sort of freedom that developers want. It's everything they basically come and bitch at us about. You know, those are the things, well, oh, that's what they want. All right, we'll make that part of our freedom formula. You know, we'll give that to the ones that really have shown that they care about reliability in our systems. So that's SRE in a nutshell at Just Eat. Transformation warriors, is that what we are?
Agents.
Agents of change, there we go. So we thought we'd talk about the future. And I thought my version of the future would be a bit more related to AppD because that's why we're all here. And, you know, in any of our stuff that gets released now, you know, I take it for granted that my CPU will be monitored, my hard drive space will be monitored, my memory, that, you know, the alerts will be set to reasonable defaults. And you take that for granted these days. I mean, there was a time you wouldn't have taken that for granted, but I'm sure, well, I certainly hope everyone else takes that for granted these days, that you just get those things for free. But what we don't get, to me, is the business transactions. These are things that we still have to go through and set up and pick that user journey and try to, these are the ones I really care about. And that's what I want AI to solve for me. I want, you know, new components coming in, new servers being launched, new services appearing, that AppD will help show me and go, oh, look, here's a business transaction. Did you know 95% of your call center agents are using this user flow? You know, I haven't set that up as a business transaction. I don't know about that user flow, but it's there in the system. AppD should be able to detect it. AppD should be able to show it to me and then show me when it starts deviating. So hopefully we'll see some of that in the roadmap stuff this afternoon. If not, you know.
And for my crystal ball, although now I look at it, I'm slightly worried I chose a snow globe, but it's meant to be a crystal ball. My crystal ball moment is around about automation and incident resolution. And in fact, we've seen some of this with the AI machine learning announcements this morning. Quite often I come in on the morning for that production meeting and I'll look through the HipChat logs and I can see that at 2 o'clock in the morning something went bang and we fired some alerts and an engineer logged on and they did some change, but that didn't work, so they talked to another engineer and they logged on and did some change, and then between them they found the problem and they solved it, and then they ran some tests and they looked good, so they closed it down, wrote up the notes, went back to bed at 5 in the morning, and then we came in first thing and decided, okay, how bad was it? my dream is that I can come in one morning and that same thing will have happened, but we won't have woken any engineers up. And in fact, the bots, the systems that we're looking at, will have identified where they've deviated, where something's gone wrong, and they will identify what they need to do to recover those systems. And if we get really good, those dependent systems will talk to each other, and they will understand the implications of making that change. Could be a re-release, could be a fix, could be a config change, could be a scale out. But those systems will work together to resolve that. And upon resolving it, we'll run sanity checking, and upon proving that's good, we'll log it all in that same HipChat channel so that when we, the humans, come in after a good night's sleep in the morning, we can see exactly where the system was hurting and what we can do to try and alleviate that pain going forwards. And I think that step into AI, that step into machine learning is just the start of products that will help us do this more and more effectively. So that's it from us.